Hello everyone. Today I'm gonna talking about LED and lasers. In this presentation include what are the LEDs and lasers, how they are working, properties of LEDs and lasers, advantages and disadvantages, and usage areas of them. And finally, I will talk about the differences between LED and lasers. What is the LED? LED, light emitting diode, is a semiconductor diode-based light emitting electronic circuit element. It was invented in the Soviet Federative Socialist Republic of Russia in the 1920s and made into an electronic component practically applicable in America in 1962. How a LED works. The LED is a specialized form of PN junction that uses a compound junction. The semiconductor material used for the junction must be a compound semiconductor. The commonly used semiconductor materials, including silicon and germanium, are simple elements, and junction made from these materials do not emit light. Instead, compound semiconductors, including gallium arsenide, gallium phosphide, and indium phosphide, are compound semiconductors, and junctions made from these materials do emit light. These compound semiconductors are classified by the valence bands their constituents occupy. For gallium arsenide, gallium has a valency of 3 and arsenic a valency of 5, and this is what is termed a group 3 and 5 semiconductor, and there are a number of other semiconductors that fit this category. It is also possible to have semiconductors that are formed from group 3 and 5 materials. Properties of LEDs. LEDs are semiconductor materials. Its main ingredients are silicon. When current passes through it, they emit light, releasing photons. They are produced to give light at different angles. The voltage current graphs of LEDs are exponential. A serial current limiting resistor is connected to the LEDs to avoid distortion due to high current. In this way, lead degradation is prevented at non-sensitive voltage ranges. Let's reduce a constant voltage on them, just like a Zener diode. Advantages of using LEDs. LEDs are high efficiency light source. The directional nature of light produced by LEDs allows the design of luminaries with higher overall efficiency. LEDs are continually declining in price that makes LED displays extremely affordable. LEDs radiate a cold light, and they generate very little heat compared with other lighting technologies. They causes less wasted energy. Let's have a full range of colors and with appropriate missing schemas, so they can generate billions of colors. Let's have high energy efficient. They are now capable of outputting 135 lumens over watt. They have long lifetime. Their lifetime is 50 hours or more. LEDs are called solid state lighting because they are made of solid material with no filament or tube or bulb to break. LED monitors are usually lighter and thinner than LCD monitors. The fluorescent bulbs used in an LCD monitor are bigger, heavier, and they can make the monitor bulkier as compared to the materials used in LED monitors. LED monitors offer better and sharper color reproduction as compared to LCD monitors, and the production of LED monitors has been increased, which makes them more affordable choice. Disadvantages of using LEDs: temperature dependence, voltage sensitivity, color rendition, area light source, light pollution, efficiency droop, impact on wildlife, used in winter conditions, thermal runaway. Usage areas of LEDs. LEDs were previously only used as decorative due to high cost. As a result of the increase in the advantages of LED use in studies on LED technology and its positive effects on the environment. It is used in routine lighting in developed countries. In this regard, studies are being carried out in our country for the use of LEDs for general lighting in this area. So much so that you can limit the use of LEDs to your imagination. And we can continue with lasers. What is the lasers? When an electron goes into a high energy orbit, it will want to return to the energy orbit to which it belongs after a while. In doing so, it reveals the energy it has as a photon, the fundamental particle of light. When you think of a scuba television, for example, what you see on TV are actually phosphorus atoms that are stimulated by high-speed electrons and emit light of different colors. Lasers, light amplification by stimulated emission of radiation, are optical sources that control the way excited atoms emit their photons, forming them into a harmonious beam. For the first time in history, Albert Einstein proposed stimulated radiation in 1917. In 1960, Theodore Maiman performed laser movement at optical frequency and found a Rabi laser. In all laser types, energy is pumped into the environment to raise atoms above the excitation threshold. For example, an intense flash of light or electrical charge discharge pumps energy into the environment that will stimulate a large number of atoms. Main component of a laser. All the laser comprise of three basic components. First, active medium. Second, excitation source pump. Third, reflection mirrors resonator. Lasers differ only in terms of active medium or excitation process. Main properties of lasers: coherence, directionality, high intensity, monochromality, short pulse duration. Types of lasers. Several ways to classify lasers. Mode of operation, active medium. You can see in this page. Benefits or advantages of lasers. It employs passive cooling technique in its design. It consumes less power. It is very efficient. It offers excellent efficiency with a very high operation duration. It is very easy in operation. Semiconductor lasers are cheap and economical to afford. It offers long life, highly monochrome, tunable, and continuous beam. It is simple in design, construction, and compact in size. Mirrors are not required, unlike other laser types. The drawbacks or disadvantages of lasers. It is expensive and hence more expenditure to the patients requiring laser-based treatments. It is costly to maintain and hence more cost to doctors and hospital management. Increases complexity and the duration of the treatment based on laser devices or equipments. Lasers cannot be used in many commonly performed dental procedures. Laser beam is very delicate to handle in cutting process. It's harmful to human beings and often burns them during contacts. Differences between LED and lasers. The important distinction between LED and laser lies in the operating theory. The emitted light is a consequence of the recombination of charge carriers around p-n junction, whereas laser emits light as a result of photons entering the atom, which forces them to unleash identical photons. The laser acts on the theory of stimulated emission, and the LED functions on the principle of electroluminescence. Speaking of LEDs, they have multiple wavelengths, and they and are polyatomic. They can also appear to generate just a single color while producing a number of wavelengths. Via laser light diodes, real single wavelengths are realized, and this is the basic distinction between how LEDs and lasers operate and are used in different applications, contributing to a host of other variations. Major differences between LED and lasers. A maintained distinction between LED and laser is also provided by the light beam emitted by LED and laser. The light produced by the LED consists of different colors, while a single color is the light beam created by the laser. Significant variations were also created by the working concepts of LED and laser. The LED acts solely on the electroluminescence principle, which implies electron luminance. On the other side, laser acts on the spontaneous emission principle. Electrical to optical efficiency for LED is uh, between 10% and 20%, where laser efficiency is up to 70%. LED requires limited applied BS and works at comparatively low levels of current, but high driving power is necessary for the laser, and high injection current density is required. The junction area is the other maintained distinction between LED and laser. In the case of the laser, the field of the junction is very small, and in the case of the laser, light is allowed to enter from a very small area. The LED junction field, on the other hand, is broader. Light is therefore permitted to travel across a large field. In LEDs and lasers, the distribution of charge carriers such as electrons and holes is also distinct. The concentration is very high for the laser, although it is very low in LED. Laser is therefore used in the medical field in the surgical instrument when it has such energy that is can also cut the materials in contact with it. For the LEDs, for different K uses, the LED is known as the optical source. Electroluminescence is the K concept behind its operation. In this process, as electrons and holes melt at the junction, the forward BA's PN junction emit photons. The LED is a junction diode that controls the amount of electricity to flow through it. And lead is made from semiconducting compounds containing gallium and other materials to produce different colored light energy. Gallium, indium, and nitrate compounds contain blue and green LEDs. Gallium and aluminum and phosphate compounds, on the other hand, create red LEDs. LEDs are an incredibly inexpensive and handily light source. Due to their low performance strength, they are typically used for multimode fibers. They are used up to a speed of around 30 Mbps in low data rate optical transmission networks, where it is not a major issue to scatter output pulses because of dispersion. Lasers. The laser is working under the theory of stimulated radiation emitted. It is thus termed light amplification by radiation stimulated emission. By hitting the atoms with the same direction, the stimulated emission is the emission of the photon. When electrical energy is supplied to the electron at the lower power frequency, the extra energy delivered to it will be consumed by the leap from the valence band to the conduction band. The process is known as absorption. Laser diodes are made of gallium arsenide phosphate and are used in fiber optic systems. A laser with a cent grain size will generate a power output of around 10 watt. Laser on-off turn speeds are higher than LEDs. The spectral spread is around 1 to 2 nm or much smaller than the LED. Consequently, laser dispersion is not a concern relative to LEDs. Lasers are also more suited for the monomodal and high bit rate devices used for optical fiber systems. These days, people never think about throwing a party without a laser lighting system. The laser lights are quite popular as party lights. Thank you for listening me.